Okay, here we are, friends. We're going to do this quick little video lesson on circular motion. This was probably the easiest thing for me to leave for you while I went away, but I thought it might be easier to do a quick little video lesson instead of just leaving notes and having you try to sort your way through that. So what we're going to look at today is objects traveling in circular motion. Okay, so just as a quick review, we started off the outcome looking at objects traveling in horizontal acceleration. Then we looked at objects traveling in vertical acceleration, so going up or coming straight down. Then we looked at objects following a trajectory or a parabolic path. And now we want to look at objects traveling in a circle. Okay, so basically these are things like if you're on a merry-go-round, or maybe you have an object tied on the end of a rope and you are traveling, like you're going to whirl it around in a circle, or maybe you are lassoing horses, let's say, where you make that circular motion. What we know is that if there is an object that's traveling in a circular path, and let's say the rope breaks, then this object is going to fly off of its path tangent to the circle. So what a tangent line is if you've talked about it in a math class, is it's like basically if you could think of like if you have a curve and you zoom in and zoom in and zoom in and zoom in and you zoom in far enough, it would make a line. That's what the tangent line is. It's just touching, but it'll break off and fly in a straight line path along that pathway. Okay, we're going to talk about centripetal force more in the next outcome, but I'll just leave that for now. But for right now, you should know that the velocity of an object is always tangent to the circle. And what we're going to do is we're going to derive three formulas. So we're going to have three new formulas to add to our formula sheets and a couple of new variables. Okay, so what we're going to be talking about or assuming is that the object traveling in a circle is traveling at a constant speed for the duration of the circle. So if it's traveling in a circle, what I know is that the distance that it travels is equal to the circumference of a circle. And if you remember, the circumference of a circle is 2 pi r. So my formula for velocity becomes, if it's distance over time, becomes circumference, which is 2 pi r. Okay, now the one thing you need to remember from Physical Science 20 is that the time, because on the bottom here I have distance divided by time, so the distance it travels is going to be the circumference of the circle. The time that it takes to go around one time is called the period, and that is capital T. Okay, if you remember that from Physical Science 20. So here is our formula for velocity in circular motion, and you should see that formula on your formula sheet, but it's 2 pi r divided by the period. And in just a little bit, we will add some variables onto your sheet. Okay, the other formulas I want to develop are for centripetal acceleration. So here's the first one. That one should be on your formula sheet. So notice that there's the little c here. So that stands for centripetal or circular acceleration. It's the square of the velocity divided by the radius of the circle. And then we're going to derive another formula just by substituting in the value that we found for velocity into that formula. So that's going to become AC equals, instead of v squared, we know that just from right up above that v is equal to 2 pi r divided by t squared divided by the radius. So if I do a little math on that, so I'm going to distribute the squared to everything inside of that bracket. That's going to become 4 pi squared r squared over t squared. And then instead of writing the double fraction, I'm going to change that to divide r. So I know that if I want to divide by r, I multiply by the reciprocal. So this becomes 4 pi squared r squared over t squared times 1 over r. And then what happens is I can cancel one of my r's away. So I end up with my second formula for centripetal acceleration, which says AC equals 4 pi squared r divided by t squared. Okay, so we have three formulas that should be on your formula sheet under circular motion. Okay, what you'll probably want to do is also add to your formula sheet where we're defining our variables. So we already have v for velocity. R is going to be radius of a circle. Most often we're going to deal in meters, right? We want to kind of keep kilograms, meters, seconds as our base units. Capital T is the period. That is the time for one rotation. That is measured in seconds. Okay, so that's the time for one cycle. We also have a little c, which is just circular acceleration, and that is in meters per second or meters per second squared. Okay, so those are kind of our new variables for you to add to the formula sheet. We're going to do one example and then you can do some practice on your own. Okay, so let's look at this example here. It says, suppose that a 500-gram mass is swung in a horizontal circle at the end of a 65.0 centimeter long string. It makes 10 revolutions in 8.25 seconds. Okay, so what information do I have here? If I go through and highlight numbers with their units, that sometimes helps. And we're going to pair those up with the variables that they belong to. I find this section is very kind of like Mickey Mouse. It's kind of a little bit more like Physical Science 20, where you just have formulas and you have to match up the information. So what I know is that I have a 500-gram mass. So my mass is 500 grams. Now we're going to work always in kilograms, meters, and seconds. So we're going to convert that into kilograms. So we need to move it 3 spots over. So it's going to become 0.500 kilograms. It's swung on a horizontal circle at the end of a 65 centimeter long string. So that means the string is 65 centimeters, and then it goes around in a circle from there. So that is actually the radius. So 65.0 centimeters, and again, we are going to work in meters. So we'll move that 2 spots over. So it's going to become 0.650 meters. Then it tells me that it makes 10 revolutions in 8.25 seconds. So that is giving me information about period. Remember, the period is the time for one revolution. So we're going to need to divide, because it's 8.25 seconds for 10 revolutions. So if I divide that, that gives me the time for one revolution is 0.825 seconds. And then I can just go ahead and choose my formulas. So I want to find velocity in A. So my formula for velocity is 2 pi r divided by t. I just have one of them. So velocity is equal to 2 times pi times 0.650 meters divided by 0.825 seconds. And when I put that into my calculator, I get 4.9504. Giving that one as a final answer, I'm allowed 3 significant figures. So that's going to become 4.95 meters per second for my velocity. And then for B, it wants me to calculate the acceleration. So again, you can use any formula that you want. We have 2 of them there. So if you're confident you didn't make a mistake calculating your velocity, go ahead and use the first formula. Otherwise, use the second one. Just remember that if you're going to use the first formula, you need to keep the 4 decimal places that are required so that you don't lose accuracy in your answer. So acceleration is equal to v squared over r. So this is going to be 4.9504 squared divided by the radius, which is 0.650. And I actually still have even more digits on my calculator still. So I would just keep those values in there and square it, and then divide by 0.650, which ends up giving you 37. I'm just going to go straight to my end answer here because this is the last question. So it's going to be 37.7 meters per second per second. Okay, so that's the acceleration of the object. So it's quite easy. You're just putting the information, pairing with variables, and then plugging it in. Okay, so there are 3 questions down here below for you to try. I would like you to have those done for Monday, or Tuesday, I guess, because it's Thanksgiving. On Tuesday, we will move on to the last of the lessons in this outcome. We'll finish it up, and then it's going to be time to move on.